Hello, folks. So in this video, I want to actually talk about my ideas. So it's kind of like me brainstorming on my ideas, and these are ideas for what I want to work on, and it could be a startup by itself, a company by itself, basically, or it can be a side project for now, which can turn into a startup or a company basically in the future, right? And these are just tech ideas. I haven't done any market research to understand the feasibility of running a startup and starting a startup, and how much profit it will give you, how much revenue in what timeline and whatnot. And will it be bootstrapped or does it need funding, seed funding and whatnot, right? So let's get started. So people come up with many ideas. These are just ideas. These are nothing without execution. So my focus is mostly on say hard problems, and I am the kind of person who wants to actually solve a problem once and for all. So when I say once and for all, I just don't mean once and I'm done. I'm also saying once and do it for other people also, and not the way like once and for all time, but more like for all people also, right? So fix it once, solve it once, and then provide it for everyone, like as a service or whatever, right? As a platform, as a open source software, right? For example, there are a lot of common tech problems. Say something as simple as authentication authorization. Companies like Auth0, ORY, Ori. Ori is a new company, Auth0 is older. Open source software like Keycloak, all of these solve for authentication, authorization, and managing basically identity and access management stuff, right? So identity and access management is a popular problem, and it's being solved by cloud service providers, CSPs, basically, like Amazon Web Services and then Google Cloud Platform and Microsoft Azure and whatnot, DigitalOcean, so many cloud services. They do some complex stuff, and they provide some complex services and features. And AWS has something called, I think, Cognito and whatnot, separate specific services to help you with authentication and authorization in your application, and basically identity and access management. And within the cloud also they have identity and access management, right? So you need it in any kind of place, including your application, including your infrastructure, platform as a service, infrastructure as a service, software as a service also, right? Let's say other common cross-cutting features that people would require are logging, like let's say monitoring and observability, right? Some people wonder what's the difference. One of the interesting ideas that I got from this company called Honeycomb, which is actually doing some interesting work over here. They say that I think monitoring, according to them, I believe it's monitoring. Monitoring, according to them, is getting answers to questions you already know. So these are questions you already know. Like for example, what is the CPU usage? This is a question that I already know and I'll ask, and I know I'll ask. Right? This is a question I know. This is a question that I know I will ask when there's a problem, and I'm ensuring that there's a metric or some way to get the value and to visualize it and whatnot. And I'm collecting that value. I'm actually tracking that value, right, over a period of time. So it's as a time series data, basically, right? So that is monitoring. And then observability is basically getting answers to questions that you didn't know, like unknown questions, right? So how do you answer questions? How do you get the answers to questions that you don't even know when you are building your solution, or when you are building your say monitoring and observability solution stack or stack or whatever, apart from your application, which is the solution to some problem. So you have to architect for that, right? Like, how will you architect for some unknown, right? I think the way Honeycomb does is they collect all the data. Let's say if it's HTTP request, they collect all the data around the HTTP request. Say HTTP request headers, request, maybe even the request method, request URL path, request body if there's a body, and then the response, and metadata like time it took and whatnot. And I guess they store it all, and then when someone is looking for data around the request or the response, they get it all. Basically, they have to store a lot of data basically in this case, because you don't know what's the question you'll ask, right? So you could ask any question. What was the method? What was the exact request payload? What was the exact response payload? And what was the time it was sent? How much time did it take for the response to come back and whatnot? Which time zone was the server in and whatnot? What was the speed of the internet? I don't know. So you can ask any kind of question, right? So you basically collect all the data. Then I think Honeycomb has this concept of sampling. So they don't get the data for all the requests. I guess they get the data for some sample of requests, like usual concept of sampling. So basically, observability is you are trying to answer questions that you never thought answers to. It's that you never thought you would need answers to. Or you never thought you would ask and will need an answer to. So yeah, I mean, and then in monitoring you have logging. So there's melts, MELTS, like metrics, events, logs, traces. I think S is nothing, but probably span. Traces and span are all related. I think span is one part of a trace, big trace. So yeah, I mean, a lot of companies, softwares try to solve, apart from things like authentication, authorization, they solve stuff like monitoring and observability. Even in monitoring, there are specific niche areas, like for example, error monitoring. Companies like Sentry do error monitoring, error logging related, like error related stuff. And then they try to fan out, I think, and do more in the monitoring and observability. And they try to do stuff like application performance monitoring. And then, of course, there are many companies in the monitoring and observability, industry or area or domain. Popular ones are Neuralink, and there is Dynatrace and whatnot. There are many companies, and there are some companies that got acquired by bigger companies and all. So yeah, I mean, there are like too many companies actually, right, in the monitoring and observability space. And then there are in these domain. I mean, in this domain, there are many niche domains. These are like error logging, error monitoring is one, application performance monitoring is one, and then there is downtime monitoring or uptime monitoring. So companies like, I think, Better Stack have services for this, apart from having services for logging and all that. So log platforms, log management platforms is a thing by itself. A lot of, I think, security teams use logging platforms. For example, the last company that I worked for, Ola Cabs, the security team, it was called the Sentinels team. They used to use Sumo Logic to actually take care of doing a lot of processing of the logs and keeping the logs all together in one central place, so that they can show it to the security auditors for doing security audits for stuff like, say, PCI audit, which is actually a payment card industry data security stuff, right? So anything related to payments, for example, say credit card, debit card, storage, and whatnot. And I think a lot of audits need a lot of data, and you need to show the data to the people who are auditing. And for that, these people use logs. And there are a lot of solutions around logs, apart from simply just storing the logs and indexing the logs or processing the logs, and to actually ensure that it's searchable, queryable, so that you can write some queries and you'll be able to search it, query it, and understand what happened at a given point in time, what was the log, what were the logs, and whatnot. And then, so since I worked in the infrastructure side, I'm just talking about a lot of solutions on the infrastructure side, like authentication and authorization in infrastructure and application, and all this observability and monitoring and all that. And then there are solutions to problems like data related stuff. For example, you want to actually have a message broker, you want to have a stream processor where a stream of data is coming and you need to process the data. Then you need to have data solutions, right? I don't know about stuff like data lake and whatnot. There are a lot of people working on some really complex problems over here. Apparently people who created and worked on Hadoop are working on some interesting stuff related to data lake, I heard. This was, last I heard was like years ago, so they're probably doing some more great stuff. And then they'll probably put artificial intelligence into the mix and all that to help users onboard faster, probably, so that they can use natural language and talk to the computers and softwares instead of trying to type SQL queries or whatever queries they want or need, right? So for example, in the last company that I worked for, Ola Cabs, they used to have this business intelligence team who need to write queries like, for example, how many users were using the platform, how many users were paying this much, or what was the pricing and whatnot. And there are a lot of jobs running for all of this data to get queried and generated as a report, to generate reports, basically a lot of jobs to generate reports, because the business, the management wants to see these reports, right? So to see these reports, you need to run a job and like process some data. The job will run some queries and whatnot, and you need a platform for that, right? I think Ola was having, I mean, they have a team, and they were having an overhaul basically of their big data platform, and it was using stuff like Hadoop, Python, Spark, PySpark, and then basically Apache Spark based stuff, I think. So Apache, a lot of Apache software foundation software. So Hadoop, Hive, and then I forgot, there were many names. I have some friends over there who can probably tell me the kind of software they use from Apache Software Foundation and outside, and basically a lot of things that companies like Cloudera and others provide, and then companies like DataStax or Databricks and whatnot. So those are the people who actually build and contribute to Apache Software Foundation softwares, and also provide enterprise services. They're probably, or they are kind of the pros, professionals, experts, pros in these softwares. So they're experts and they are reliable, and they can provide a service very well on these services, on these softwares. So data related services like message brokers, streaming platform, data streaming, some data stream processing platforms, like softwares that need or applications that need Apache Flink, or I don't know. I mean, there are many things around this, superset and what. And then there are databases, by the way. There are different kinds of databases. There are structured databases and then not structured databases, where the data structure or the way you think about data is structured versus not structured. Basically, they call it as SQL versus no SQL, or relational versus not relational. And in relation, it's straightforward. It's table format. There are rows and columns, and usually you work with rows, and the way you store data is very specific to that. And then there are databases like non-relational, which are like, for example, columnar, where there are still some tables, some columns of sorts, I think. And then columnar, there is key value store, there is graph database, there is document database, where you have documents, for example, usually JSON documents, right? So yeah, I mean, and then there are some databases that have both, right? I think there are more, and there's like geospatial databases, there are time series databases, right? So yeah, there are many databases, and a lot of companies require these services. So yeah, I mean, data related stuff, a lot of companies require this. All right. For example, in Ola, I think they were using mostly MySQL, and if they were using PostgreSQL, they were not self-hosting it. Instead, they were using Amazon RDS. So yeah, I mean, there is a lot of scope for and there are a lot of companies using Amazon RDS, or some hosted Postgres as a service. Some of them just run it on their own. So you can provide Postgres as a service, database as a service, which is a very interesting thing for me, because I just love it for some reason. I think it's pretty cool. Maybe when it becomes not so cool, I'll probably work on more things. But until then, I'll probably keep considering that running a database as a service is pretty cool. Someone might say, or many might say, that it's pretty stupid to start off a database as a service company, because there are so many databases and so many database as a service offerings out there by many companies and many organizations and startups. But then I think I can still make things work. I can work out things. And let's see. In Tamil, they say if there is a will, there's a way. In Tamil, they say it as manam irundha margam undu. So yeah, manam meaning if you have the will, margam meaning there's a way. So will and way, and or intention, or liking or want. If there's a want, there's a way. If you put your mind to it. So what else? So I've spoken about some of the stuff I've worked on. So logging, monitoring, a lot of infrastructure stuff, and then databases, authentication and authorization, and secrets management. I've self-hosted Vault, HashiCorp Vault, and then Kubernetes. Yeah, I've actually not self-hosted Kubernetes, but I think a lot of companies would want to self-host Kubernetes, or would want to make Kubernetes management easy. And usually I see a lot of cloud service providers making it pretty easy and cheap to run a Kubernetes cluster, but I don't know if people still want to self-host. I don't know. So Kubernetes is something that I have worked on a bit. To be honest, I want to work more on it, because I feel like I still haven't worked enough on it. But it's been a lot of years working with Kubernetes, and Kubernetes is releasing a lot of new stuff these days. Too many new releases and whatnot, and new features. Yeah, I mean, what else? I mean, there's only one popular competitor for Kubernetes, which is HashiCorp Nomad. I mean, in the open source world. In the closed source world, I think it's Elastic Container Service (ECS), along with Fargate. So I think, but ECS is very basic, is what I've heard, but it's good enough, is what I've heard. Anyways, along with Fargate, you don't even have to manage your worker nodes, I believe. So you just say run this container, and you're done, right? It's pretty cool. And so basically a container orchestration platform as a service. And what else? People want CI/CD, continuous integration, continuous deployment, continuous delivery, and maybe continuous deployment. So they need CI/CD. So if they're using GitHub, they need self-hosted GitHub runners. If they're using GitLab, they want GitLab to be self-hosted source code management solutions. They want GitLab CI/CD to be self-hosted. They want Jenkins to be self-hosted, or Argo CD, along with Argo workflows for CI, and then along with Argo events and whatnot, Argo rollouts. Right? They want Argo as a service. There's a company behind Argo, I think. I think it's called Akuti, I forgot. They want CI/CD as a service. There are closed source companies around this, Circle CI, Travis CI, so many popular companies. And then people want what else? I mean, there's Tecton and whatnot, but I don't know what people use these days. Mostly I've heard only Jenkins and Argo recently, but I am biased, I guess, towards these. Tecton, I have to check how many people use it, what is the adoption and whatnot. And then what else? And then people need support in general, on call, right? They need experts in any of these and all of these, right? Any database stuff and whatnot. People usually even pay for support, enterprise support and whatnot. So I'm just wondering which area to pick up. Currently, my eyes are on database as a service, and for example, provide databases as a service. For example, starting with something like Redis or PostgreSQL, or some niche, for example, say etcd, and become experts, contribute to the database, and maybe write tools and services around etcd, provide etcd as a service, database as a service, provide I don't know, I mean, be experts in concepts like Raft, and I think etcd uses Bolt DB, and probably a forked version of Bolt DB. So because Bolt DB I think has stopped development at some point after it reached some sort of maturity. So become experts in Bolt DB, which is actually I think an embedded database. So it embeds, so etcd uses that, I believe, for the storage engine part. I have to check it out. So I'm still not well versed, but I don't consider that as the problem to start off, because I can learn and I want to learn. I mean, everyone starts at some place, and I'm fine to start over here and be like, I'll do it. It's fine if I don't know, I'll learn. So I'm going to learn stuff like how to learn, how do I learn, because everyone learns in a different way, I think. Visuals, audio, text, and whatnot, imagery, or is it through moving images, basically, like videos, movies, and whatnot, storytelling and whatnot. Like, how do you learn? I sometimes learn by teaching, so a lot of people do. So mix of these is also a thing. So And how do you learn hard things? How do you learn hard things easily or make it digestible? Like how do you make hard things digestible, and how do you ensure that you just remember enough and don't have to remember too much, right? And about business models, database as a service, it's straightforward. Provide subscription or provide some usage-based thing instead of subscription. Only based on usage, provide the database as a service. For example, I can provide serverless databases also, right? Wherein I can reduce the cost. But then, what are the pros and cons of serverless databases, especially for the user, the client, the application using the database? All these are a thing that I need to consider, and I need to actually build capability skills to learn about serverless databases. And there are companies doing serverless databases like serverless Postgres and whatnot. There's this company called Neon.tech, Neon basically. So they have forked Postgres. They've made a copy of Postgres and they've started doing stuff around serverless Postgres, and they are up and running, and they're providing a service, I think, already, and whatnot. So yeah, so it is possible, clearly possible, right? And then what else? Basically, serverless compute is a popular thing. So yeah, or else maybe business model would be something like um, yeah, run SaaS is the easiest. Others are a bit harder. For example, provide support, become experts and provide support to startups and whatnot. Another idea is this is support for databases, for example. That is the main thing that I'm eyeing on. Databases always, and start with a specific database. And then next thing would be start off solving a problem for a startup as a service company, but solve the problem and keep the code to yourself or open source it. The code is not owned by the company, and do they pay anything? Maybe they don't have to, because we are solving it for them for kind of for free. The cost kind of for free, but not for free. The cost they're paying is we keep the software to ourselves, or which doesn't make sense, because they'll be like, then if you don't give me the software, then what do I do? So instead we can do something like keep it open source, so that now we build the open source software and in such a way that it can solve the problem for the startup, and slowly we'll start looking at how it can solve the problem for other startups and make the solution generic as possible. And then at some point provide it as a product to many people with enterprise features and whatnot and solutions, or provide the complete software open source and provide support, expert opinions and support as a service, and what do you say, paid support, wherein you can actually get some features built very fast by paying us something, by supporting the team behind the open source software. So this is kind of like building open source software and giving it for free to startups and having them as early adopters, but at some point they will actually help us by supporting us. But to start off, they don't have to pay anything until they see some value at least, right? But the thing is, they don't have to pay probably too much, because it's open source and they'll be like, other people are going to use it too, and you will probably get money from them also. So yeah, it's a tricky thing to price it, because open source, and they might be like, why should I pay you? It's open source. A lot of people think that way. And what else? Yeah, I mean, and I think there's a lot of room for improvement when it comes to the pricing model, the business model. For example, database as a service, companies like AWS, they provide RDS, and sometimes companies are using it really depends, right? Because database, you want to keep it as close to your application as possible so that the network latency is pretty minimal. So let's say you're running your application and say it's going to be running in a specific data center in an actual physical region in some place in the world. So for example, it can be in India, and if your database is in the US, there's quite some latency compared to if it's in India, right? And there are companies doing edge databases and whatnot, where the databases are at the edge, right? So it's very close to the users. Anyways, so yeah, and your applications are also at the edge, I believe. So yeah, and that's what makes sense. You have to ensure that when you provide a database as a service, you cover as many regions as possible so that the applications connecting to the database are pretty close to the database, and they get pretty good speed. Network latency, right, is pretty low. Network latency is pretty low, and the speed of the queries are of course fast. Read query, write query, whatever it is. So and also stuff like cloud companies have costs when it comes to data transfer, basically anything on the internet. So if your clients or customers application is on, say, Microsoft Azure, but your database is on Amazon, Amazon's data transfer in basically ingress or input or whatever you want to call it, there will be some cost, but I think ingress is zero usually on AWS, but egress, which is out, so when the database sends back the data, the response to the application on Microsoft or any other cloud, then that's like uploading for that server, for the database server, and for that there's a cost for the data transfer out from AWS to an internet. Or you have to do something like VPC peering and whatnot, or some sort of peering, or have a VPN and whatnot, like some network in such a way that the application and the database are in a private network, and it's as if they are communicating in a private network, and the network latency still has to be pretty low. Or you can say that I'll provide the database as a service in your own cloud account. You can bring your own cloud. So there's this concept of bring your own host or cloud, BYOH or BYOC. And you basically say, we will take care of the management of the database. You just provide me the server, the virtual machine, and it will run on that. The database will run on that and will be managed by our management service, which is automated. And the management service software will reside somewhere else, anywhere, preferably close to the database where the physical location of the database is. Or you can say, I'll provide the management service also as a software to you, and you can run that service and you can pay more. So this is something that this company called Scale Grid does. So and because this, why would someone do this? So that their application and our database are pretty close and to each other. And another reason is people get a lot of credits from their cloud services, either through their cloud services directly because they are early customers of the cloud or whatever, or they have a good relationship with the cloud or whatever, or some investor, some venture capitalist, VC, provided their funds in the form of cloud credits, because they have got some cloud credits from the cloud services. So they provide AWS credits, and if your database is on Microsoft Azure, and or any cloud, and it's under your own account, the account of the service provider, database as a service provider, they can't get the credits, they can't use the credits, right? So they would rather actually use their credits, and they would rather want to self-host their database So you can still provide your database as a service software and the management service and whatnot, and they can use their credits by running it on their own EC2 or compute, say Lambda or whatever, and they'll just pay you for the software, right? But the pricing becomes a bit tricky, because do you price the product or do you price the usage? How do you know the usage? You have to send the data, metadata from their account, from their compute, the EC2 or Lambda or whatever, to your, say, service, which collects metadata, something like telemetry, metrics or whatever. And will they allow that? Will the company, the client, allow that and whatnot? Or do you just price the product without checking usage and whatnot, because you can't check usage? Or you provide both models and then tell them that we can either price it based on usage, or you just price it based on the product, some subscription or whatever, or based on upgrades we provide, features we provide and whatnot, and price it. It's going to be tricky, but yeah. So that is one. The whole idea of this whole providing a service and providing it for self-hosting itself is tricky, wherein people get licenses and whatnot. And when there is server software, it's very very tricky, because people don't run a server or one service on one machine alone. They can run it on many machines. They can scale it, assuming it's horizontally scalable, and usually you can scale it horizontally apart from vertically. So when you're running it at high scale, means it means you are using it a lot. So licensing, providing licenses, validating that license and whatnot, you'll usually want to do some sort of either put that information in the software itself, or start using some external service on your end and communicate with that external service to do the validation of the license and whatnot, which the client has to allow. If they are in an air-gapped environment, like where there is no internet or no network connectivity to external world in general, then how will you do validation of that? That was one idea I actually had, wherein you build a license server software to help with this sort of server side licensing. I mean, a lot of companies have client side software, for example, IntelliJ and whatnot, who have license keys, and they do, I'm sure they'll have some sort of license server which checks validation and whatnot. I don't know if license keys and this whole sort of validation of licenses are still a thing. Yeah, I mean, if it's still a thing, and I believe it is, then that's also some solution that needs to be built in case you're going to be using that. So yeah, these are some ideas, high level ideas. Low level ideas would be, what is the database that I want to start working on? How do I learn those? How do I learn hard things in general? How do I form a team for running a database as a service company? Because it's not simple, because database as a service, database is a very critical software in any application, and depending on the usage of the database and depending on the criticality, say the number of clients or users the application has, and the revenue the application has, the company has, the criticality of the database increases, and accordingly the service level agreements and SLAs basically has to be there. Like, for example, if it goes down for even a minute, what do you do? Like, do you say that I'll give back some money or whatever? But because even if the cost of running the database is, let's say, $100 per month, it's a small database and whatnot, and then 1 minute it goes down, you pay back them some money, or you pay back the whole $100, but does it still actually cover their costs or cover their loss of revenue when the database was down for that one time, depending on the peak hours of their service and whatnot. So you need to understand that, because they might have lost thousands of dollars when the database completely costs only $100 per month. So because the database was down for 1 minute, let's say. So it's important to understand the SLA and tell them that this is the service that we will provide for this cost, and if you need more service, it will come at a higher cost. And you need to have people working at those hours, peak hours, for the customer, for the end users, right? Where the end users are using your customer's application, and that application is talking to the database, and the peak usage of the database is some set of hours, and you need to have support during those hours. People should be on call, so you should have people who are going to be up and running, who are going to be awake and working during those hours. And if there is any support issue, then they work on the support, or they just work on the service, like any features for the service, right? Or they just chill, of course. So let's say it's an Indian client. I'm in India. It's easy to work during Indian hours and the peak hours and whatnot. And the client is Indian, and the end users are also Indians. And peak hours are during the usual awake hours of India, and I'm in India. But let's say the client and end users are in the US, then it's completely like some 12-13 hours difference, I think, depending on where they are in the US and whatnot. Then I need to be awake at different hours, or I should have a support person working in the US, which is easier, because I think the idea is called follow the sun model. So you just have someone who works in the US time, and they are working on the servers, and you work async with them, and then you basically try to have a global team who can actually work at around the clock, 24/7, but during their time zone it's not 24/7. For them it's just normal working hours, but according to the client they have someone or the other from some time zone, preferably their own time zone or close to their time zone, who is working at that time in shifts. And basically not in shifts, more like this is working during the day for them, and that just happens to be the time when the support is needed. So everyone just works during the day, because this is something that I'm very serious about, and it's very close to my heart, that people shouldn't just have to sacrifice their sleep to work, and surely not on a very regular basis, maybe once in a year probably, right? So that means I'll probably have to build, or I must build, not probably, I must build a really good service and have some really simple SLAs that I can actually adhere to and stick to and obey, depending on the criticality of the service, criticality of the database service, and ensure that I don't overcommit, and instead I undercommit and over deliver, under promise and over deliver. And so yeah, I'll grow slowly, probably with some small startups who have a small growing user base or client base, and when they grow, we'll also grow, and slowly the maturity of the database as a service will also improve, so that slowly, we don't like go ahead and like find a client whom we can't cater to. Instead, we find a perfect fit for ourselves, a client that we can cater to, so that we grow with them, and when they are pretty big, we are also pretty big, and we can actually cater to them. But we should ensure that we are growing at a really good pace, either faster or at the same pace as the client, preferably faster, so that faster than the fastest client that we have, who is growing really fast, and so that we are not lagging behind, and we can provide a good service, and we can obey the SLAs that we say. SLAs, SLOs, SLIs, whatever we have, right? We can stick to it, and we can provide the service smoothly, in a very smooth manner, seamless manner, and not struggle. And that way, I think we won't lose sleep, at least not so much. So yeah, I mean, these are some of the ideas that I had. I'll probably talk more and brainstorm more. So yeah, that's all I had for this video. I'll see you in the next one. Bye bye.